Imagine believing your entire life in one single story about how the universe was born. Billions of people, textbooks, university courses, everything built on the seemingly solid foundation of the Big Bang Theory. Then humanity launches the James Webb Space Telescope, and suddenly the images it sends back seem to whisper something unsettling. You may have misunderstood something important. Galaxies appearing far earlier than they should. Black holes that grew far too quickly. Heavy elements that, according to older calculations, simply shouldn't have had time to exist. In this video, we'll explore some of the most surprising discoveries made by the James Webb Space Telescope. We'll look at real observations and discuss why some scientists are now talking about a possible crisis in cosmology. Step by step, we'll break down what Webb has actually shown us and which parts of our traditional models of the early universe might need serious revision. Let's briefly revisit what the classical Big Bang model actually says. According to the standard cosmological model, about 13.8 billion years ago, the universe began in an extremely hot and dense state. First came a tiny fraction of a second known as cosmic inflation, when space itself expanded at an incredible rate. Then, the universe began cooling, allowing protons and neutrons to form. Soon after, the first simple elements appeared, hydrogen and helium. For hundreds of millions of years, the universe remained dark. Astronomers call this period the Cosmic Dark Ages, a time before the first stars ignited. Only after about 300 to 400 million years did the first stars and primitive galaxies begin to form. Older models predicted that these early galaxies should be small, faint, and extremely poor in heavy elements, and detecting them should be incredibly difficult. The James Webb Space Telescope, launched in late 2021, was designed specifically to look deeper into the early universe than any telescope before it. Its main mirror measures over 6.5 meters in diameter and is made of gold-coated hexagonal segments capable of capturing extremely faint light from distant cosmic objects. But Webb's real advantage is something else: infrared vision. As the universe expands, light traveling across vast distances becomes stretched. Blue and visible light gradually shifts into red and infrared wavelengths. This means that to observe the earliest galaxies, those formed shortly after the Big Bang, astronomers need a powerful infrared telescope. And that is exactly what Webb was built for, to peer into the first few 100 million years of cosmic history. Scientists expected to see early galaxies, but what Webb revealed surprised almost everyone. One of Webb's most striking discoveries is the existence of extremely bright and massive galaxies at very high redshifts. In simple terms, we're looking back to a time when the universe was only around 300 million years old. And yet, we already see objects that resemble large modern galaxies. One example is a galaxy known as MOM Z14, observed at a redshift close to 14. That means we see it as it existed when the universe was roughly 280 million years old. According to older theoretical models, this period should only contain the earliest seeds of galaxies, small clusters of newly forming stars. Instead, Webb shows compact but extremely bright objects, already containing vast numbers of stars. Even more puzzling, their light indicates the presence of heavier elements, like oxygen, carbon, and nitrogen. These elements are forged inside stars and released into space when stars explode as supernova. So how did the universe manage to form stars, let them evolve, explode, and enrich entire galaxies with heavy elements, all within just a few 100 million years? Another remarkable discovery involves complex systems of multiple galaxies observed about 800 million years after the Big Bang. One such observation revealed a group sometimes referred to as a galactic quintet. Instead of isolated young galaxies, Webb sees something resembling a cosmic metropolis. Several galaxies interacting, merging, and gravitationally distorting each other. Again, time becomes a major problem. Traditional models suggest that such large and complex structures should require hundreds of millions or even billions of years of gradual growth through mergers of smaller galaxies. Yet Webb shows these dense systems already in place less than 1 billion years after the beginning of the universe. Spectral data reveals significant amounts of oxygen and other heavy elements in these galaxies. This implies that multiple generations of stars must have already formed and died incredibly quickly. In many research papers, astronomers now describe a growing gap between theoretical predictions and actual observations. But the surprises don't stop there. Webb has also found evidence for very early supermassive black holes. One example is an object called CAN-UCS-LRD-Z86, which appears to host a growing supermassive black hole when the universe was only about 570 million years old. Supermassive black holes, millions or even billions of times heavier than the Sun, usually sit at the centers of galaxies. Our own Milky Way has one. However, according to previous models, building such enormous black holes should take an immense amount of time. Matter must gradually fall inward, stars collapse, and accretion processes slowly increase the mass. Yet Webb shows these objects forming astonishingly early. Even more intriguing are the mysterious sources astronomers call little red dots. These compact red objects could represent early black holes surrounded by dust, or extremely dense regions of rapid star formation. Either way, they suggest something very unusual was happening in the early universe. At this point, you might hear dramatic headlines claiming, James Webb disproved the Big Bang, but science is rarely that simple. The Big Bang theory is not just a single idea. It is a framework supported by multiple, independent observations. For example, we have the cosmic microwave background, the faint radiation left over from the early hot universe. We also observe the expansion of the universe, confirmed by measurements of distant galaxies moving away from us, and the predicted abundance of light elements like hydrogen and helium still matches observations remarkably well. So the Big Bang itself remains strongly supported. What Webb is challenging are the details of how the first cosmic structures formed. Scientists are already exploring several possible explanations. One idea is that the first stars were extremely massive, perhaps hundreds or even thousands of times heavier than our Sun. Such giant stars would burn fast and explode quickly, enriching galaxies with heavy elements much sooner than expected. Another possibility is that black holes form directly from the collapse of massive gas clouds, skipping the normal star stage entirely. Researchers are also examining whether our assumptions about dark matter or dark energy need adjustment. And finally, there are more radical proposals involving alternative cosmological models. For now, however, most scientists believe the answer will likely come from improving our understanding of the physics of the early universe. The James Webb Space Telescope has not destroyed the Big Bang theory, but it has clearly challenged our comfortable picture of the early universe. It suggests that galaxies may have formed and evolved far faster than we once believed. It hints that supermassive black holes may have started growing almost immediately after the cosmic dawn. For us, this is an extraordinary moment in scientific history. We are living in a time when fundamental questions about the origin of the universe are being tested with real observations. Every new image from Webb pushes the boundaries of our knowledge a little further, and the most surprising discoveries may still lie ahead. If you want to explore the mysteries of the cosmos with us, make sure to subscribe to Deep Space Discoveries, like this video, and stay tuned for more journeys into the deep universe. See you in deep space.